Hi guys, this is a quick introduction to my impulse gamma spectrometry software that I've just written. I hope you enjoy it. Now, to install Python is very simple. You get it from the Python website, and once you have Python installed, it's pretty much a matter of opening the command prompt and typing in a few simple commands. And here I am listing the directory, and you can see in the impulse directory we have a file called requirements.txt. You need to install the dependencies in that one, so type in pip3 install --r requirements.txt, and the computer will import those special requirements that are needed for my program. Next thing, you just change directory to the code directory, and when you list the code directory, ls -il there, you will see that there's a file called run, and this is the one that starts the program and the one that you need to start to run the program. So Python 3 space run.py and hit enter, and your program should launch automatically and bring up your default browser. And here you go, the default browser has come up and it's already found the pulse. As you can see, you can switch sample rates, and you'll see at 48 kilohertz you get a tall narrow sample, and 190 kilohertz you get a more smoother sample, which is going to work better for us. On this page you also can adjust the chunk size, the pulses to sample, and the sample length. Now let's hop across to the spectrum page and let's start recording a simple spectrum. So we'll do the background first. So I'll call this one for background and hit start. And as you can see, the spectrum starts building on the screen straight away. We've set this to 1000 bins and a bin size of 30. And this will automatically stop after 1 million counts, but you can change this number while it's running, and it's a convenient way to stop the spectrum. If you just change the number of counts to 0, the spectrum will automatically stop. We can display energy per bin, which exaggerates the high energy peaks. We can also display it in log scale, and we can of course turn on calibration with 3 calibration points, using a polynomial, second order polynomial fit. So it's pretty neat. Now we're just going to skip forward a bit here. So we're going to see in a moment, we're skipping forward to 95,000 counts, and we're almost there, and at 100,000 counts this spectrum will stop. Almost there. And there we go, reached 100,000, and you can see the spectrum automatically stops counting. What I'm going to do now is I'm going to copy the name of this file that we just recorded, background. I'm going to copy that and copy that into the comparison spectrum. And now I'm going to put a small thorium source in front of my detector. And we're going to hit start. And it should start counting in just a minute. There we go, and now we are recording a thorium spectrum, which is a very weak source. But now we can compare that to the comparison spectrum, and you can see that in the red line, and you can see the weak thorium source is standing just above the comparison spectrum. Now, by switching on the subtract comparison, the spectrum turns green, and it shows you the difference spectrum. So I've designed this to be easy to operate. There's no hidden windows with settings that we have to concern ourselves about. I'm trying to fit everything on the front panel here so we can access it while we're recording our spectrum. I also have a library of isotopes built in. We can access that by simply typing I/ and the isotope, and it will bring up the peaks in the library. Thanks for watching.